So, you've got an idea for a project. Great. And the nice thing is that you already have a rough idea of how the application should look and feel. And now it's finally time to build it. But hold on for a second. Before you write any code, you should probably, design your database schema. Easy, right? Just pop open ChatGPT, type in create me a database schema, and boom, copy paste it and you are done. Yeah, no, I don't think so. Not only will you introduce huge security issues and bugs into your application, but let's be honest, nobody is hiring you with that mess.
No! God, please, no! No!
But with this video, everything will change. We are going to build a full-on entity relationship diagram from scratch, with best practices in mind and scalability and performance front and center. We will also cover key concepts like primary keys, foreign keys, and of course all types of relationships. So without any further ado, let's go! Alright, so step number 1 is to first of all define your idea, the core feature set, and just in general what your application will do. And that's what I have done right here. So I want to create a course platform similar to, like, for example, Coursera or Udemy, and the features should include users who can sign up and enroll in courses, instructors who can create and manage their own content, courses that are organized into categories and made up of individual lessons, enrollments that track which users have access to which courses, and reviews, so users should be able to create reviews for individual courses. And also I want to implement progress tracking to create a rich user experience. And my recommendation to you would be to always create such a description. You want to really go through the idea and think through it. Create a description, create the feature set. What do you want to create? How will everything work with each other and stuff like that, and put it into text as I did right here. So now I have my feature set right here. I defined all of my features. Now I know what I want to build. But before I continue with the actual entity relationship diagram, I have to first of all know what models I have to create. So I have to probably create some sort of user model, maybe a courses model. I often interchange the word model and table. They are the same thing. The database term is table, but in Prisma, in my favorite ORM, you call a table a model. So in this case, we will first of all have a user model, because when users sign up, I want to store general user information like the name, email, and stuff like that. Then we will also have a course model, and this will store the general course information, the title, maybe a slug, and stuff like that. Then we will also have lessons, and of course a course has multiple lessons. Lesson number 1, introduction. Lesson number 2, implement AWS or something like that. Then I want to also have an instructor model. Not every user will be a instructor, and in the instructor table I want to store instructor specific details, like for example the bio. Hey, I'm Jan, I'm XYZ years old, I'm a programmer, stuff like that. Maybe also the experience and stuff like that. I don't really want to put that into my user model. For that I want to create a separate model, and that's why I right here have this instructor model, or in other words table. Then I want to also have a category table, and that's because I want to organize my courses. Not every course is the same. A few courses will be about development, other courses will be about music and stuff like that. Then I want to also have the review model table, and this will allow enrolled users to create a review about a specific course. But here's the thing, one user should only be able to create a review for one course in which he is enrolled into. Then I want to also create a user lesson progress table, and this will be there to track the user progress, because again I want to implement progress tracking, and I have to know when a user completed a specific lesson, and that's why I created this table right here. So we now know what we want to create, and the next step is already to create an ERD. So right here I created a little checklist. Step number 1 is to start planning the platform and core entities. We are finished with that. I can mark this as completed. completed. Step number 2 is to create the base structure, the ERD in general. And that's what we will do right now. So right here, I'm using Eraser as my platform. You can use any other platform. This video is not sponsored by Eraser. Nevertheless, I will have a link down below in the YouTube description for you guys. Inside of here, I want to click on the plus icon. I want to create a diagram as code, and I want to create an entity relationship diagram. So right here, they already created a few demo tables, models. I don't need them, so I will just delete everything right here on the right side. Also, I will zoom out a bit and then I can make this a bit bigger. So again, with what should we start? Well, I want to now create the base structure. This means I want to implement all of these tables. Thankfully, we already defined all of them right here, which means I can do a lot of copy pasting. Nevertheless, let's start with the first table, which will be the user table. So this will be user. Then I want to use these array brackets, and inside of here, we can first of all define an icon. This will be the user icon, and then also a color, which will be blue. Then I want to just open this like a standard object, and inside of here we can define all of the properties. So what properties will the user have? Maybe a username, why not? This will be of type string. Then also an email, which will be of type string and unique. So I will just say @unique, and then maybe also a password. Okay, maybe you should not store the password as a string in your database, hash it or something like that. But for demo purposes, this is fine. So the user will have in total 3 properties: the username, email, and password. Let's also create the second table together. So the second table will be for the course. I can just copy this, paste it inside of here. Again, we want to use these array brackets. For the icon, this will just be TV. Then for the color, this will be purple. And then I can again open these object brackets. So what properties will this course table have? Well, for example, a title. This will be of type string. Then also a description. This will also be of type string. I want to also create a slug. This will be of type string, and @unique, because the slug is always unique. This is what we will use to pretty much query the course. So that's what I would use in a production example. I would use the slug to query the course because this is very beneficial for SEO. Is there anything else that I want to add right here? I don't think so. The title, description, and slug, this is already fine enough. So now we already created 2 tables, but as you all know, in total we have 8 tables. So I will now create them myself. You will also do it, and once finished, I will come back. Alright, so I now created all of the entities, all of the tables, as you see right here, and let's quickly review them. So first of all, we have the user table with a username, email, and password. Then I have an instructor table with a bio, website URL, and Twitter username. Then I have a category with a name, description, and category image. I also have a course table with a title, description, and slug. Then I have a lesson table with a title, description, thumbnail URL, and video URL. I also have an enrollment table, but this is empty for now because there's no real info that we want to add inside of here. There's no title, no bio, nothing is really needed inside of here, and we will actually use it for something else. I will show it to you in a second once we start with relations. I also have this review table with a rating and comment. So a user can create a rating between 0 and 5. So 5 stars is the best. 0 stars means that you failed. And then I also have a user lesson progress table, and this is also empty for now because there's no real info that I want to add inside of here. No title, no slug, nothing like that. So we are now finished with step number 2, and step number 2 was to create the base structure. So I can mark this as finished, and the next step is to optimize the database structure. So if I go back to my canvas or to this code field, what can we update? So let's start with the user. We have a username, an email, a password. Is this incorrect? I'm asking you. You tell me. Does this look correct or is this incorrect? Well, this is actually incorrect, because here's the thing. I gave this table the name user. This is fine, this is not the mistake, but I uppercased user. A database name or a table name itself should always be lowercased and singular. I often see that people uppercase the name and also make it plural. This is a mistake in my books, at least. Please always leave the name lowercased, and also it should be singular, not plural. I made also the same mistake right here with the instructor. This should be lowercased and singular. The category is fine, the course is fine, the lesson is fine, the enrollment is fine, so the rest is correct. Then let's look at this instructor. Is this instructor table correct? Well, we already know that the name is correct. It's singular and also lowercased. But what about this website URL and Twitter username? What format do I use right here? Well, I use camel case. The first word is lowercased, the second word is uppercased. Website, uppercased URL. But this is incorrect. Whenever you create a database, you don't want to use camel case, but instead snake case. This means what I want to do right here is add an underscore and then say URL, website underscore URL. The same thing is also true for the Twitter username, Twitter underscore user underscore name. I want to do the same thing also for the category, again category underscore image. Then I can also update the lesson, thumbnail underscore URL, and then video underscore URL. And now you might also ask me, hey Jan, what about this user lesson progress table? Should I also use snake case right here? Good question. In a real database, you would want to also use snake case. So this right here is, for example, an example of real SQL, and here you see that they also use snake case, because this is how you do it the professional way. This means right here I will also convert it into snake case. I want to do another very important optimization, and that's to add created at and updated at timestamps. Why should you add them? Good question. So recently I was doom scrolling on Twitter, and then I found this project right here, opencut.app. This is like an open source video editor. Who cares? They had a waitlist, and their waitlist got spammed. Now sadly they already deleted the waitlist right here, but I found a screenshot, and as you see right here, this waitlist had 655,000 people join. Is this correct? No. This application got attacked, some sort of user spammed this waitlist with fake emails. And here's the thing, if you don't add a created at timestamp for this table, then you won't be able to delete all of these fake signups. Because here's the thing, this fake user, this malicious user created some sort of bot. This bot created probably like thousands of signups per minute. If your table would now have a created at timestamp, then you could see, hey, probably from this time to this time I had malicious users, I can just delete all of these rows. But since this user probably did not add any created at timestamp, he was not able to delete all of these fake signups. So in my opinion, it's a good practice to always implement created at and updated at timestamps. And if you are 1,000,000,000% sure that you won't need them, then sure, don't add them. But if you don't really know if you might need them later on, then please just add them. These few bytes won't destroy your database. This means for the user table, I will just create a comment right here, optimization, and then I want to create a created at timestamp. This will be of type date time, and then at default now. This means it will just create a new date whenever a new row is generated. Then I want to also add the updated at timestamp. This will be of type date time at default now. And I will now just copy paste this into every table. I literally mean it, into every table, because I don't really know if I might need it later on. It's always better to have it than to not have it, because here's the thing. You can't add these properties later on. You have to add them right at the start whenever you create your project. So now we are almost finished with our optimization, and there's only one more thing missing, and that's primary keys. Because here's the thing, in most cases you will probably use a relational database. For example, this is my website marshallcode.com, and I use Postgres. Postgres is a relational database, and since I use a relational database, I have to have primary keys. But what is a primary key? Good question. So a primary key is needed to ensure that each record is unique and also easily retrievable. Because sometimes you want to find a unique record in your database, like for example, one specific instructor, and for that you have to have a unique value. And in most cases, you use the primary key for that. Now here's the thing, what could a primary key be right here in the user table? So a primary key has to be unique, not null, and not undefined. So the email is not unique, the password is not unique, but the username is unique. So this means in theory, I can say, hey, this is a primary key. No, this is a huge mistake, because here's the thing. Business logic should never be a primary key. The username is business logic. This means we can't use it. The same thing is also true, for example, for the category. The name is unique. It's not null. It's not undefined, but it's business logic. So what's the solution? Well, the most common solution, or the only good solution, is to use an ID. This will be, for example, of type string or int. It does not really matter. And then PK, primary key. I will then just copy this ID and paste it into every table. So now with this ID, we have a value that is unique, not null, not undefined, and also not business logic. And if we look at the canvas in more detail, then you will also see all of the tables right here. We have the review table, the user lesson progress table, the course table, the lesson table, the enrollment table, the instructor table, the user table. All of the tables are defined right here with, of course, an ID that is also a primary key. So we have finished. We can go back to the document. We have finished with step number 3, and now we can continue with the final step, and that's to create the relations. But how do you create a relation? Good question. So at its core, a database relationship is like a logical link between two or more tables, and it defines how data in one table is connected to data in another table. And there are in total 3 types of relationships. You first of all have one-to-one relationships, one-to-many relationships, and many-to-many relationships. So if we now take, for example, the user table and the course table, then this would mean that one user could only have one course, and one course could only be related to one user. Now this of course does not really make any sense, because one user can be enrolled into many courses. A one-to-many relationship would mean that, for example, one user can be enrolled into many courses, but each course, each individual course, has to be related to one user. This again does not make any sense, because of course one user can be enrolled into many courses, but each course can have many customers, many users. And then we have many-to-many relationships. And this means, for example, that many users can enroll into many courses, and each course can also have many enrollments, many users. And that's also what would make sense in this example, because we have many users and many courses. This means we want to have many enrollments. So now we already know a bit about relationships, the types of relationships, and now it's time to also implement them. So I can zoom out a bit. I want to again open the editor. And first of all, how do you create relationships right here in Eraser? Good question. So here they have this syntax help button. So right here they have all of the relationship types listed. So you create a one-to-many relationship with this smaller than sign. You create a one-to-one relationship with this dash, and a many-to-many relationship is created with this smaller than and bigger than sign. But we won't actually use this. Right here, we will create a joint table, but I will come to that a bit later on. Let's for now start with our first relationship. And what's the first relationship that we should start with? Well, in my opinion, everything always starts with the user, because what does a user, a customer do? Well, a customer signs up, and this means this info is stored in your database. So let's start with the user. So what's the first relationship that we can create? Well, we have a user and we have an instructor. What relationship do we have right here? Again, let's go to our diagram. Is it a one-to-many relationship or maybe a many-to-many relationship? Well, in this case, only a one-to-one relationship would make sense because one user will be able to have one instructor profile, and each instructor profile will be related to one user. And that's what you want to do in most cases because you don't want to have a user with multiple instructor profiles. So again, if I scroll a bit to the bottom, I will right here create a new relationship. I want to get my user.id because the ID is the primary key. Then I want to use this dash because I want to create a one-to-one relationship and I want to relate this user to the instructor. But here's the thing, how do you create relations in a relational database? Well, you want to use primary keys and foreign keys. But what are foreign keys? Well, a foreign key is there to create relationships between tables and also it maintains data integrity. And then this foreign key is there to reference a primary key. Let me show you a diagram. We have two tables. First of all, table 1 and then table 2. This table 1 has a primary key, department ID. And then this table 2 has a foreign key, department ID. And now this foreign key will be linked to the primary key from table 1. And that's how you create a relationship. You want to have a primary key from your main table and then a foreign key for the second table to create a relationship. So right here at the top I have my instructor table and I can go underneath this Twitter username and I want to create an user_ID. This will be of type string at unique fk. So this is the foreign key that relates to my user ID itself, the primary key. And then if I scroll again to the bottom, I can get my instructor.user_ID. If I now again open my canvas in general and zoom out a bit, then you will find this line right here. We have the user table and the instructor table. And right here it says 1-to-1, primary key, foreign key. So this right here is the one-to-one relationship. Let's continue with the next relationship, and this will be between the instructor and the course. So again, if we look at our diagram, what relationship would make sense? Well, the one-to-many relationship makes a lot of sense because one instructor can create many courses, but each course can only be related to one instructor. So let's again go back. Underneath the user ID, we can get our instructor.id. This is the primary key. Then we want to use this less than sign to create the one-to-many relationship. And we want to relate to the course.instructor ID, the foreign key. But we haven't created a foreign key yet. We want to go to the course table and then underneath the slug I will create an instructor_ID foreign key. So this will be of type string at unique and then fk. If I scroll again to the bottom, I can get the course.instructor ID. So again, if we look at the canvas, then you will see right here this line and it says 1-to-star. One-to-many. Then the next relationship will be between the course itself and then the lesson. So what relationship would make sense right here? Well, again, it's the one-to-many relationship. One course can have many lessons, but each lesson has to be related to one specific course. So I can get my course.id, then I want to get the less than sign and I want to relate it to the lesson.course.id. This means again, I want to go to the lesson table and then underneath the video URL, I can create a course_ID property. This will be of type string at unique fk. Then again, if I scroll to the bottom, I can get the lesson.course.id. And this again creates a one-to-many relationship. Then what's the next relationship? Well, we have the category table and then also the course table. What relationship would make sense there? A course has a specific category, maybe development or music, and also this category should be singular. So one course can only have one category. Well, in this case, again, a one-to-many relationship makes a lot of sense. one category can have multiple courses, but each course can only have one category which is related to it. So right here underneath the course ID, we can get the category.id, we want to get the less than sign, and we want to get the course.category ID. Again, we did not define the foreign key, so right here in the course underneath the instructor ID, I will create a category underscore ID, which will be of type string at unique fk. Then again at the bottom, I can get the category underscore ID. So now let's again look at our diagram. So we have this user table, and then we also have our course table. As you all know, one user can be enrolled into many courses, but each course can also have multiple users, multiple customers. So what relationship would make sense right here? Well, a one-to-one relationship won't work. A one-to-many relationship won't work. In this case, we want to use the many-to-many relationship. Again, one customer can be enrolled into many courses. Each course can have multiple customers, multiple users. So how do you create a many-to-many relationship? Good question. You want to use a joint table, or you want to create a joint table. And we already did that. That's the enrollment table. And this enrollment table will now be connected to the user and also to the course. And that's how you create a many-to-many relationship. So let's again open the editor. We want to go into this enrollment model. And then inside of here, we want to create two foreign keys, the user ID and the course ID, because this table right here will have two relations. So I want to create the user underscore ID. This will be of type string at unique fk, and then also the course underscore ID, which will be of type string at unique fk. At the bottom, we can now create the relations, because here's the thing, we have to now create two relationships. First of all, between the course and this enrollment table, and then also between the user and again this enrollment table. So underneath the category, we can get the user.id. We want to create a one-to-many relationship, and this will be related to the enrollment.user.id. And then we want to also get the course.id, the primary key. We want to create a one-to-many relationship, and this will be with the enrollment.course.id, our foreign key. So again, if we look at our diagram, we now have our enrollment table, and this enrollment table has two relationships. First of all with the course, and then also with the user. This creates this many-to-many relationship. Again, this right here is called a joint table, and that's how you create many-to-many relationships. Then let's continue. We now have this review table. Let's also implement it. Let's create a relationship. So as you all know, enrolled customers can create a review. But here's the thing, an enrolled customer can only create one review for each course. A customer shouldn't be able to create, for example, 5 reviews for one course. No, one review per course. So what relationship should you use right here? A one-to-many relationship, a many-to-many relationship, or a one-to-one relationship? Well, you want to create a one-to-one relationship. But here's the thing, you don't want to do that between the user and review table, but instead between the enrollment and then the review table. So right here, I can get my enrollment.id, then I want to get this dash because I want to create a one-to-one relationship, and this will be with the review.enrollment ID. Again, let's go to the review table. Underneath the comment, I want to create a enrollment underscore ID, which will be of type string at unique and then fk. At the bottom, I can get the review.enrollment ID. This means now each enrollment can have one review for one specific course. The enrollment table is a joint table. This means this table has a user and a course. For example, let's say we have course XYZ. This will have one user ID and then this course ID. And then we have another course, it's called ABC. This will have the same user ID, but this time a different course ID, which means we have another enrollment row. And that's why we can create another review. That's why we have a one-to-one relationship and not a one-to-many relationship. And now we are almost finished. There's one more table left, and that's the user lesson progress. So here's the thing. With this table, we want to track the user progress. But what relationship type should we use right here? A one-to-one relationship, a one-to-many relationship, or a many-to-many relationship? Well, we want to again create a many-to-many relationship, or in other words, this is a joint table. And this table will have a relationship with the user and then also with the lesson. So let's go back to our editor. We can open right here this table, user lesson progress, and here I want to again create two foreign keys, and this will be again the user ID and the lesson ID. So first of all, user underscore ID, this will be of type string at unique fk, and then also lesson underscore ID string at unique fk. And inside of here, we will now again create one-to-many relationships, but since we use a join table, it will result in a many-to-many relationship. So right here, I can get the user.id, the less than sign to create a one-to-many relationship, and this will be related to the user lesson progress.user ID. I want to also get a lesson ID. Again, we want to create a one-to-many relationship with the user lesson progress.lesson ID. And I guess we are finished. So if I again go back, then you will see this diagram right here. And this diagram is finally finished. So let's analyze it. Let's see what relations we have right here. So again, everything starts with the user table. This user table has a few relations. First of all, with the instructor, we have a one-to-one relationship. One user can have one instructor profile. Each instructor profile is related to one user. We also have a relationship between the user and the enrollment. One user can have many enrollments, and this enrollment table is a joint table. Our user also has a relationship with our user lesson progress, because again, a user can at the end of the day pretty much complete multiple lessons, and that's why we need this joint table. We also, for example, have our category. So this is a table which stores multiple categories, and this has a one-to-many relationship with the course, because each category can have multiple courses. So the development category can be related to multiple courses, but each course has to be related to one category. Also, the course has a relationship with the instructor. One instructor can have multiple courses. Each course has to be related to one instructor. And then this course also has a relationship with the lesson, because one course can have many lessons, but each lesson has to be related to one course. And then also this course table is related to this enrollment joint table, because again, each enrollment has to have one user and then also one course. And then we also have the review table. Each enrollment can have one review, not multiple reviews. Sure, at the end of the day, one user can create multiple reviews, but pretty much each enrollment can only have one review. And yeah, that's already it, guys. We created our ERD, Entity Relationship Diagram. We used all relationship types. I hope you enjoyed this video. I hope you could learn a lot. Please don't forget to like and subscribe. It would mean a lot to me and my heart. So please do it. And now enjoy your day, and I hope I can see you in the next one. So bye bye.